Uturuncu. Uturuncu is a dormant 6,008 meters, 19,711 feet, high volcano in Bolivia with two summit peaks. It consists of a complex of lava domes and lava flows with a total volume of 50 to 85 cubic kilometers, 12 to 20 cubic miles, and bears traces of a former glaciation, even though it does not currently carry glaciers. Volcanic activity took place during the Pleistocene and the last eruption was 250,000 years ago. Since then Uturunku has not erupted but active fumaroles occur in the summit region. The volcano rises within the Altiplano Puna volcanic complex, a larger province of large volcanoes and calderas which over the last few million years have emplaced about 10,000 cubic kilometers, 2,400 cubic miles, and sometimes very large eruptions. The volcano has two summits, with a fumarole field between them. Underneath it lies the so-called Altiplano Puna magmatic body, a large sill formed by partially molten rocks. Starting in 1992, satellite observations have indicated a large area of regional uplift centered on Uturunku, which has been interpreted as an indication of large-scale magma intrusion under the volcano. This might be a prelude to large-scale volcanic activity, including supervolcanic activity and caldera formation. Geography and geomorphology. Uturunku lies in the Sur Lipas area of southern Bolivia, southeast of the town of Catina and just northeast of the Eduardo Avero Indian Fauna National Reserve and the Cordillera de Lipas. A former sulfur mine is situated on the mountain, close to the summit, and was considered to be one of the highest in the world. A winding road leads up on the mountain and additional roads pass along the northern, eastern and southwestern foot of Uturunku. The region is almost uninhabited and the volcano was little known until ongoing large-scale ground deformation was discovered in the early 21st century. Since then scientific interest has increased, including a reconnaissance mission carried out by scientists in 2003. Additionally, the volcano has been used to reconstruct the regional history of glaciation. The term Uturunku means jaguar in the Quechua language. Structure. With 6,008 meters, 19,711 feet, elevation, Uturunku is the highest mountain in southwestern Bolivia and dominates its geomorphology, rising about 1,510 to 1,670 meters, 4,950 to 5,480 feet, above the surrounding terrain and giving a good view of the surrounding mountains from the summit. The volcano has two summit peaks 5,930 meters, 19,460 feet, and 6,008 meters, 19,711 feet, high, about 1 kilometer, 0.62 miles, apart and separated by 5,700 meters, 18,700 feet, high saddle. It is a stratovolcano with remnants of a crater, and consists of lava domes and lava flows erupted from a number of vents in the central part of the volcano. About 105 lava flows propagate outward from the central sector of the volcano, reaching lengths of 15 kilometers, 9.3 miles, and featuring levees, flow ridges and steep, blocky fronts over 10 meters, 33 feet, thick. The northernmost lava flow is known as Lomo Escapen with a length of 9 kilometers, 5.6 miles. It is also the largest lava flow at Uturunku. 5 lava domes south, west and northwest of the summit form a northwest-southeast trending alignment that appears to be an older volcanic system. The southern of these domes have volumes of about 1 cubic kilometer, 0.24 cubic miles, and the western dome bears traces of a large collapse. The broad edifice covers an area of about 400 square kilometers, 150 square miles, and a volume of 85 cubic kilometers, 20 cubic miles minus 50 cubic kilometers, 12 cubic miles. It appears to consist entirely of lava flows and lava domes. While the occurrence of pyroclastic flow deposits was reported at first, later research has not found any evidence of explosive eruptions. Aside from volcanic deposits, there are also traces of glaciation which has smoothened the slopes of Uturunku, as well as Pleistocene and Holocene alluvium and colluvium. Lakes and rivers. Several lakes surround Uturunku. Mamacamu lies on the eastern foot of Uturunku and is bordered by steep slopes, while Laguna Celeste is located northeast, Choju southeast and Lower Mayu south of Uturunku respectively. Beach terraces. Deposits of diatomaceous earth and former shorelines are visible around the lakes. The Rio Grande de Lipas flows along the western foot of the volcano and receives tributaries which originate close to Uturunku's northeastern foot. It eventually flows into the Salar de Uyuni. These watercourses are usually confined between steep bedrock walls and are characterized by gravelly beds, Anastomosing channels and wetlands which are used to keep llamas and sheep. Geology. Regional. The eastward subduction of the Nazca Plate beneath the South America Plate has generated 3 volcanic belts within the Andes, including the Central Volcanic Zone which spans parts of Peru, Chile, Bolivia and Argentina and includes Uturuncu. Aside from Uturuncu, it includes about 69 Holocene volcanoes in a high elevation region, including the potentially active volcanoes Eruption, Alcaparuma, Akinquilcha, Lake, Azufre, San Pedro, Pitana, Sircaber, Lacancaber, Guayax, Calachi, and Acamarachi. Local. Uturuncu is formed about 100 kilometers, 62 miles, east of the main volcanic front in the western Cordillera, in a terrain formed by various volcanic and sedimentary rocks of Miocene to Quaternary age. The region is characterized by the Altiplano High Plateau, which reaches an elevation of 4,000 meters, 13,000 feet, and in terms of dimension is only exceeded by Tibet. The 8.41 million years old Vilamo and 5.65 million years old Guacha ignimbrites underlie the volcano and crop out in the Catina River Valley, while the 4 million years old Vilamo lavas are found southwest of Uturuncu and are partly buried by the volcano. The crust in the region is about 65 kilometers, 40 miles, thick. Volcanic activity in the area occurred between 15 and 10 million years ago, and Cerro San Antonio, a heavily eroded 3 million years old Miocene volcano with a westward opening collapse scar, lies just north of Uturuncu. Other volcanoes from east counterclockwise to west are the Cerro Panitos caldera, Cerro Lipas, Sunikira and Catina volcanoes as well as many more minor volcanic centers. Many of them are formed along northwest-southeast trending lineaments such as the Lipas Kernsley and Pastos Grandes Cogina lineament that passes through Uturuncu. Geologic history and Altiplano Puna volcanic complex. The geological history of the region is complex. After subduction commenced in the Jurassic, 26 million years ago, the breakup of the Farallon Plate into the Cocos Plate and the Nazca Plate was accompanied by an increased subduction rate in the onset of the Andean orogeny. This subduction process at first involved a relatively flat descent of the Nazca Plate until 12 million years ago, after which it steepened. Beginning from 10 million years ago, then the Altiplano Puna volcanic complex formed, with a flare-up occurring during the Miocene. It covers an area of 50,000 square kilometers, 19,000 square miles minus 70,000 square kilometers, 27,000 square miles, of the Altiplano Puna in Argentina, Bolivia and Chile and consists of a number of calderas, composite volcanoes and about 10,000 cubic kilometers, 2,400 cubic miles, of ignimbrite. Uturuncu lies at its center, but unlike Uturuncu, most surrounding volcanic systems have been characterized by explosive eruptions, including several so-called super eruptions with volcanic explosivity indexes of 8 at Cerro Guacha, La Picana, Pastos Grandes, and Vilama. Over 50 volcanoes in the region are potentially active. Within the last 2 million years, the Laguna Colorada, Tacio and Puripica Chico ignimbrites were erupted in the surrounding terrain. The 4 million years old Etana and 3 million years old Pastos Grandes ignimbrites are other large ignimbrites in the area, while the 10.33 plus or minus 0.64 million years old San Antonio ignimbrite is more sparse. The Altiplano Puna volcanic complex is underpinned at about 20 kilometers, 12 miles, depth by a wide magmatic sill where rocks are partially molten, the Altiplano Puna magmatic body. Its existence has been established with various techniques. It extends over an area of 50,000 square kilometers, 19,000 square miles, and has a volume of about 500,000 cubic kilometers, 120,000 cubic miles, with a thickness variously estimated to be between 1 to 20 kilometers, 0.62 to 12.43 miles. It has been referred to as the largest reservoir of magma in the continental crust of Earth. The Altiplano Puna magmatic body is the source of magmas for many of the volcanoes in the Altiplano Puna volcanic complex. In addition, about 500,000 cubic kilometers, 120,000 cubic miles, of brine are contained in the rocks underneath Uturuncu. Composition and magma genesis. Uturuncu has erupted dacite but also andesite in the form of inclusions within the dacite. Rocks are vesicular or porphyric and contain phenocrysts of biotite, clinopyroxene, hornblende, ilmenite, magnetite, orthopyroxene, plagioclase and quartz along with apatite, monazite and zircon within a rhyolite groundmass, and define a potassium-rich calc alkaline suite. Xenoliths consisting of gneiss, Igneous rocks and norites have also been found, of which the first two appear to be derived from country rocks while the third is a byproduct of the magma generation process. Additionally, the occurrence of cumulates, gabbros, hornfels, limestones and sandstones as xenolithic phases has been reported. Mixing processes involving hotter or more mafic magmas played a role in the genesis of Uturuncu rocks, as did fractional crystallization processes and contamination with crustal rocks. The origin of these magmas appears to relate to the Altiplano Puna magmatic body, which generates melts through differentiation of basaltic magmas first to andesites and then to dacites before being transferred to the shallow crust below Uturuncu, from where it was then erupted through buoyancy-dependent processes. Magma composition has been stable over the history of the volcano. Glaciation. Uturuncu currently features no glaciers. However, perennial ice was reported in 1956, remnants of snow in 1971, the existence of sporadic snow fields in 1994, and the summit area is occasionally ice-covered. Conversely, evidence of past glaciation such as glacial striations, glacially eroded valleys, both recessional and terminal moraines and roches moutonnées can be found on the northern, eastern and southern flanks of Uturuncu. The past glaciation of Uturuncu was not very extensive, owing to its steep flanks. One of these valleys on Uturuncu's southwestern flank has been subject to glaciology studies, which identified a former glacier originating both from the summit and from an area about 0.5 kilometers, 0.31 miles, south of the summit. This only weakly erosive glacier deposited 5 sets of up to 5 meters, 16 feet, high moraines within the shallow valley. The lowest of these lies at 4,800 to 4,850 meters, 15,750 to 15,910 feet, elevation, and appears to be a product of an early last glacial maximum between 65,000 and 37,000 years ago, earlier than the global last glacial maximum. Afterwards, not much retreat occurred until 18,000 years ago. During the Pleistocene, the snow line was about 0.7 to 1.5 kilometers, 0.43 to 0.93 miles, lower than today. Conversely, the uppermost of these moraines is about 16,000 to 14,000 years old and correlates to a glacial advance in the Altiplano that has been correlated to the maximum growth of the former Lake Tauca north of Uturuncu and a wet and cold climate associated with Heinrich Event 1. At this same time 17,000 to 13,000 years ago, shorelines formed around the lakes that surround Uturuncu. Lake Tauca may have been a source of moisture for Uturuncu. After 14,000 the glacier receded at the same time as climate warmed during the Bowling Alred warming and the region became drier. Climate and vegetation. There is little information on local climatology, but mean annual precipitation is about 100 to 200 millimeters per year, 3.9 to 7.9/year, or even less than that, most of it originating in the Amazon basin to the east and falling during December, January, and February. This low amount of precipitation is not adequate to sustain glaciers even though the summit of Uturuncu lies above the freezing level, but it is enough to generate a seasonal snowcap on the mountain. Annual temperatures in the region range between 0 to 5 degrees Celsius, 32 to 41 degrees Fahrenheit, and in 1963 the snowline was reported to exceed 5,900 meters, 19,400 feet, elevation. The regional vegetation is relatively sparse at high elevations and gets classified as Puna grassland, with low biodiversity. Quinoa woods and polylepis trees are found on the lower slopes of the volcano. The trees reach 4 meters, 13 feet, height and form forest. They have been used as a source of tree ring climate records. Birds such as flamingos make up much of the animal life in the area and are concentrated at open water bodies. Indian mountain cats, southern viscaches and vicunas form the rest of the animal life. Eruption history. Uturuncu was active during the Pleistocene, with a lower unit in place during the lower and middle Pleistocene, 890,000 to 549,000 years ago, and which makes up most of the peripheral sectors of the volcano, and an upper unit of middle to upper Pleistocene age, 427,000 to 271,000 years ago, which makes up its central sector and is less extensive. Several rocks have been dated through argon dating and have yielded ages ranging from 1,050,000 plus or minus 5,000 to 250,000 plus or minus 5,000 years ago. Among these dates are 271,000 plus or minus 26,000 years ago for rocks in the summit area, 250,000 plus or minus 5,000 for the youngest dated lava flow found just south-southeast of the summit, and 544,000 years for the Lomo Scapo lava flow, while the aligned lava domes have been dated to be between 549,000 plus or minus 3,000 and 1,041,000 plus or minus 12,000 years old. Overall, Uturuncu was active for about 800,000 years. Volcanic eruptions at Uturuncu were effusive and involved the emission of voluminous lava flows, 0.1 to 10 cubic kilometers, 0.024 to 2.399 cubic miles, between pauses lasting between 50,000 and 180,000 years, with a mean eruption rate of less than 0.00006 cubic kilometers per year, 1.4 times 10⁻⁵ cubic miles / (a-0.00027 cubic kilometers per year). 6.5 times 10⁻⁵ cubic miles / (a), much less than other rhyolitic volcanoes. There is no evidence of large ignimbrite eruptions nor of large flank collapses, but some lavas may have interacted with water or ice as they were erupted and were reportedly emplaced over moraines. Holocene and fumarolic activity. No large effusive eruptions have occurred since the 250,000 plus or minus 5,000 eruption, and Holocene or recent eruptions have not been reported. While it was at first proposed that post-glacial lavas existed, it is now known that the volcano has been dormant since 271,000 years ago, and glaciation has affected the youngest lava flows. The volcano is considered to be dormant. Active fumaroles occur in two fields below the summit, with a number of tiny vents located between the two summit peaks. Vapor emissions are visible from close distance. The summit fumaroles have temperatures of less than 80 degrees Celsius, 176 degrees Fahrenheit. And their gases contain large quantities of carbon dioxide, water, and larger amounts of hydrogen sulfide than sulfur dioxide, perhaps due to the latter being filtered out by a hydrothermal system. The fumaroles have emplaced abundant sulfur, and silification has been observed. Satellite images have observed relatively invariant temperature anomalies, hot spots, on Uturuncu between its two summit peaks. These temperature anomalies of about 15 degrees Celsius, 27 degrees Fahrenheit, are among the largest fumarole fields visible to satellites. The existence of intense fumarolic activity on the northwestern slope at 5,500 meters, 18,000 feet, was already reported in 1956. Additionally, a spring on the northwestern flank produces water with temperatures of 20 degrees Celsius, 68 degrees Fahrenheit. The presence of a weak hydrothermal system is likely at Uturuncu, albeit probably at great depth, considering the low temperature and spread-out nature of the fumarolic activity. There may be a shallow magma chamber below the volcano at 1 to 3 kilometers, 0.62 to 1.86 miles, depth below sea level. Recent unrest and threats. An SAR imaging has discovered that a region of about 1,000 square kilometers, 390 square miles, around Uturuncu is uplifting. Between 1992 and 2006, the uplift amounted to 1 to 2 centimeters per year, 0.39 to 0.79 in /year, in an area 70 kilometers, 43 miles, wide, but with variations over time, such as a temporary acceleration after a 1998 earthquake, a gradual slowdown either continuing or followed by an acceleration to about 9 millimeters per year, 0.35 in /year, in the few years before 2017, along with seasonal variations. Overall, the total volume change between 1992 and 2006 was about 1 cubic meter per second, 35 cubic feet per second, with a total volume change of about 0.4 cubic kilometers, 0.096 cubic miles. Such rates are typical for intrusions in the Altiplano Puna volcanic complex and historical lava dome eruptions, and might reflect a short-term rate. The deformation is centered on an area 5 kilometers, 3.1 miles, west of the summit, and is most likely of magmatic origin given the lack of a large hydrothermal system at the volcano and the depth of the deformation. The form of the deforming structure is not well known, but it lies presumably at a depth of 15 to 20 kilometers, 9.3 to 12.4 miles, below sea level. The uplifting area is surrounded by a ring-shaped area of subsidence, which is occurring at a rate of 2 millimeters per year, 0.079 in /year. The total width of deforming terrain is about 170 kilometers, 110 miles, although is it not clearly visible in all in SAR data. This joint uplift subsidence has been called a sombrero pattern, and the subsidence may reflect either a sideward or an upward migration of magma. A second, Shallow subsidence area has been found south of Uturuncu, which may relate to changes in a hydrothermal system. The deformation is most likely caused by magma intruding into the crust from the Altiplano Puna magmatic body, with the intrusion taking place at a level below that where magma accumulated prior to past eruptions of Uturuncu. It has been described as an ascending dipier or as a growing pluton, although an alternative theory holds the ascent of volatiles along a magma column reaching to the Altiplano Puna magmatic body as responsible for the surface deformation. In that case, the uplift might reverse over time. Such surface uplift has been observed at other volcanic centers in the central volcanic zone, but on global scale it is unusual both for its long duration and its spatial extent, and in the case of Uturuncu demonstrates the continuing activity of the Altiplano Puna magmatic body. In addition, there is no evidence for a net uplift in the geomorphology of the region, and findings in the terrain around Uturuncu indicate that this uplift certainly began less than 1,000 years ago and likely also less than 100 years ago. The uplift might be either a temporary deformation of the volcano that eventually deflates over time, or the current uplift might only be in its beginning stage. The term zombie volcano has been coined to describe volcanoes like Uturuncu which have been inactive for a long time but are actively deforming. Seismicity. In addition, the volcano features persistent seismic activity with occasional bursts of higher activity. About 3 or 4 earthquakes occur every day at the volcano, and seismic swarms lasting minutes to hours with up to 60 earthquakes occur several times per month. The intensities of the earthquakes reach ml 3.7. Most of the seismic activity occurs below the summit of Uturuncu around sea level, and some earthquakes appear to relate to the northwest-southeast tectonic trend of the region, although swarms occur in several aerial clusters. Whether there are long-term trends in seismic activity is difficult to estimate, as the detection and reconnaissance techniques of seismic activity at Uturuncu have changed over time. This amount of seismic activity is large when compared to neighboring volcanoes, and the seismic activity may be a consequence of the deformation, as intruding magma pressurizes and destabilizes local faults, with further triggering possible by large earthquakes such as the 2010 wall earthquake, which triggered an intense seismic swarm in February 2010. Tomographic studies. Magnetotelluric imaging of the volcano has found a number of high conductivity anomalies below Uturuncu, including a wide, deep conductor that extends to the volcanic arc to the west and several shallower ones which ascend from the deep conductor, which appears to coincide with the Altiplano Puna magmatic body. The shallow conductors appear to relate to local volcanoes such as the Laguna Colorada vent, but also Uturuncu. The latter conductor lies between 2 to 6 kilometers, 1.2 to 3.7 miles, depth, is less than 10 kilometers, 6.2 miles, wide, and may consist of molten rock with saline aqueous fluids. Seismic tomography has found a tooth-shaped anomaly that begins at 2 kilometers, 1.2 miles, depth and continues to over 80 kilometers, 50 miles, of depth. Such structures have been found at other volcanoes and explained by the presence of magma. Seismic activity concentrates at the top of this anomaly. Finally, tectonic stress patterns delineate a 40 to 80 kilometers, 25 to 50 miles, wide ring surrounding the volcano that may be prone to fracturing. Such a ring could constitute a future pathway for magma transport or the margin of a future caldera. Threats. Whether the ongoing unrest at Uturuncu is part of a benign process of pluton growth or the prelude of a new eruption or even a caldera-forming eruption is an open question. A large caldera-forming eruption could have catastrophic, globe-spanning consequences, as demonstrated by the 1815 eruption of Mount Tambora in Indonesia and the 1600 eruption of Huayna Putina in Peru. This possibility has resulted in international media attention. Evidence does not clearly indicate that a future super-eruption such as past events in the region is possible, and there is no indication for a near-future eruption, but there is certainly potential for a smaller eruption.